Hi, Algebra 1 Geometry class. It's Miss DH, third period. No quote today just because I want to make sure the video stays short. So let's go ahead and jump into Chapter 2, Lesson 3. Equations with variables on both sides. I need to proofread before I put these things up. Move one variable to the other side just as you would do a normal number and then go ahead and solve. So some of the things you will have to do before you can do this is obviously distribute, like with this first example. So we're going to end up with 2c minus 12 is equal to 9c plus 2. We need to get the c's all on one side of the equation, so I'm going to go ahead and move this one over. And notice how I obviously didn't I can move the 2 and the c as one unit. There you go. So it leaves us with negative 12 is equal to 7c plus 2. And then again, I'm down to one variable now because I've combined like terms, the 9c and minus 2c, and then I just need to solve for c. Go ahead and add the opposite. Divide by 7, c equals negative 2. And I recommend you check your answer on some of these because on the next slide I'll show you when you can get some equations that actually don't have a solution. So it's kind of good to check it either just mentally or with a calculator to make sure that you've got the right answer going on. Alright, so this is very similar basically. Since there's no distributive property going on, I'm basically going to be picking up at this step for number 2. So I'm going to go ahead and move the 5k over. I personally like to move the things so that even though I'm subtracting, I'm left with a positive coefficient in front of the variable. You don't have to do that, obviously. It's your choice which way you go. It's just a personal preference of mine. So there we go. We're left with 2k is equal to 20. Divide by 2, divide by 2. K equals 10. Please box your answers. Alright, so those are your 2 example problems. Here's an example problem for a word problem that demonstrates the same thing that we just looked at on the previous slide. A hairdresser is considering ordering a certain shampoo. Company A charges $4 per 8-ounce bottle plus a $10 handling fee per order, whereas Company B charges $3 per 8-ounce bottle plus a $25 handling fee. How many bottles must the hairdresser buy to justify using Company B? So even though for Company B the bottles are less expensive, that handling fee is what's going to throw off what's going on. So if we've got Company A and we've got Company B, Company A has basically their side of the expression looks like 4 times x, where x is the number of bottles plus the $10 handling fee, and Company B is 3 times x plus 25. So basically, I kind of want to figure out when they're going to be equal. How many bottles do I need to buy for these two to equal each other? Well, for them to equal each other, we're just going to throw in an equal sign there. So let's go ahead and do some math then. We're going to minus 3x minus 3x. That gives me 1x plus 10 is equal to 25 minus 10 minus 10. X equals 15. So this is how many bottles it is for the 2 companies to be equal. So basically, the moment I need to order over, so when x is greater than 15, the moment I need to order more than 15 bottles of shampoo is when I'm going to go with Company B, because that's when Company B is going to be cheaper than Company A. If x is less than 15, that's when I want to go with Company A. So there we go. Company A, and that's when I want to go with Company B. Alright, moving on. Alright, so here's the situation with the one solution, multiple solutions, no solution. This is going to be something that's going to come up a lot in Algebra 1. We're going to talk about it when it comes to parabolas and other complex equations, but for right now, we're just going to apply it to equations that have variables on both sides of the equal sign. The two examples that I had on the very first slide were examples of one solution problems. There is only one value of A, or one value of B, or one value for the variable that makes its solution true. But these two examples don't fit that same scenario. They're either going to have multiple solutions or no solutions. And when an equation has multiple solutions, we say it's an identity. That any number that we replace with a variable in all places of that variable for that equation is going to give a true statement no matter what. So let's go ahead and do the first one. So I'm going to distribute the 2. I'm going to have 10 minus 8a is equal to 10 minus 8a. And guess what? Already, does this equal that? Why, yes it does. So no matter what I place in for A, as long as I place the same value for A in both situations, which I should, because it's the same equation, I'm going to get a true statement no matter what. So this is what we call an identity, or a multiple solution scenario, because it doesn't matter what I put in for A, I'm always going to get a true statement. Alright, well, if that is a multiple solution / identity problem, number 2 is probably going to be a no solution, but let's go ahead and take a look at what it looks like. So I'm going to go ahead and combine like terms before I start setting up my situation. I'm going to add the opposite so I can move things around using the commutative property of addition. And I'm going to end up with 7m plus negative m plus 7. I'm going to combine my like terms, and I end up with 6m minus 5 is equal to 6m plus 7. Well, automatically things aren't going to work out, because if I subtract 6m and subtract 6m, that's obviously going to cancel out. That's going to cancel out. I'm going to get negative 5 is equal to 7, which is a false statement. Which means no matter what I put in for m, no matter what m equals, it's going to give me a false statement. Nothing's ever going to be true for this equation, which means it has no solution. Alright, let's move on. Alright, on to lesson 4 of chapter 2. Proportions and ratios, I'm not going to really define them. They're things I kind of expect you to know by now. And just a refresher that you will be using this formula this week. I hope you know it. I hope you're familiar with it. I'm not going to spend a lot of time on it. So let's go ahead and move on. Dimensional analysis, also called unit analysis, is something that I've taught, but I know it can confuse some people sometimes, so I'm going to go ahead and do a real quick example just as a refresher. A cheetah runs 30 feet in 2.92 seconds. What was the cheetah's average speed in miles per hour? So if we're doing 300 feet in 2.92 seconds, we need to get that to equal miles over hours. So let's go ahead and convert the feet first. So I'm going to multiply by something that is equal to 1 but has feet and miles in it. Well, let me see how much feet are in a mile. Give me 1 second. It's like 5,000 something, so 1 second. Alright, I'm back. I found it. So there are 5,280 feet in 1 mile. So now, basically, I have been able to convert feet into miles, because my feet are going to cancel out. But now I need to turn seconds into hours. So I know that there are 60 seconds in 1 hour. And there we go. Oh, wait. Miss TH, you made a mistake again. 60 seconds in 1 minute. There we go. I'm getting to hours eventually. And I know that there is 60 minutes in 1 hour. There we go. So I've actually gone ahead and made it so that my units work, because mile over mile, or no, Miss TH, we've already gotten to mile. Minute over minute cancels out. And second over second cancel out, which does leave me with miles over hours. And then I'm just going to do some multiplying of some fractions. So I'm going to multiply all of the numerators. So that would be 300 times 1 times 60 times 60, which I've got a calculator if you give me a second. So that is 421 miles. And now I need to multiply the denominators. 2.92 times 5,280 times 1 times 1. And that is 15,417.6 hours. So now I need to divide. Alright, so I did make a mistake. Who caught it? Yeah. 300 times 60 times 60 should be nowhere near 400. So here I am starting over again. So that would be 1,080,000 miles. And then when I do the 2.92 times 5,280, that's when I'm going to get how many hours? So that's 15,417.6. So now I'm going to go ahead and do that division. And remember, you can go ahead and use a calculator. I just did, and that's going to give you 70.05, which is approximately 70 miles per hour. So again, this is review, and I do expect you to know it, but I know this is very difficult for some of you. So let's go ahead and wipe that out. There we go. Alright, I believe this is the last slide. So proportions and cross product, I expect you all to know what cross product is. Basically means that this times that should be equal to this times that. And that's actually how you solve these types of problems, and these are called multi-step proportions. So you're going to end up with 3 times w minus 4 is equal to 5 times w plus 6. And we're going to solve for w. Alright? So because it's 3 times that, we're going to have to use the distributive property, which is 3w minus 12 equals 5w plus 30. There we go. And now we have two variables, which means we can go ahead and solve just like we did at the beginning of this video. I'm sorry this is going on a little long, but you know what? I'm almost done. So that's negative 12 is equal to 2w plus 30. I'm going to subtract 30 on both sides, which is going to give me negative 42 is equal to 2w. Divide by 2, divide by 2. W should give you negative 21. Okay, so I did take up a little space there, so I'm going to give you a second, and, well, you can pause. So I'm going to go ahead and erase. Alright, last problem, promise. Just like before, you're going to cross product. So you're going to end up with 7 times y minus 15 is equal to 35 times y plus 4. And again, distribute just like the previous problem. And really, I don't think I need to show you anymore. So I'm going to go ahead and stop right there, and I'll see you guys on Tuesday.